In this part 2 of 3 video, we'll learn about the structure of alkenes and properties of alkenes. In this section, you'll be able to describe the alkene homologous series, name the first 3 alkenes, describe the characteristics of alkene homologous series, draw the structure of the first 3 alkenes, and of course isomerism in alkenes, similar to that of alkenes. So what are alkenes? This is very important. Alkenes are hydrocarbons. In other words, they are compounds that contains only hydrogen and carbons only. And they contain one or more carbon-carbon double bonds. Alkenes have a general molecular formula of CnH2n. And they have carbon-carbon double bond as a functional group. So please take note, it must be written as carbon-carbon double bond. Do not write C _C in exam papers. You must spell the whole words carbon-carbon double bond. And all alkenes, their names ends with ENE. As mentioned in the first part video, each member of any homologous series, including alkenes, they differ from the next by a CH2 group or CH2 unit. So these are the first 3 alkene molecules. And since alkene must have carbon-carbon double bond, you need a minimum of 2 carbon. Without 2 carbons, you cannot form carbon-to-carbon double bond. So you start the first with ethene, must have minimum 2 carbon, which is C2H4, followed by 3 propene, C3H6, and 4 carbons butene, C4H8. Now, the structure formula. In all alkenes, there is a carbon-carbon double bond, which is drawn like that. So you always start drawing by drawing the carbon-carbon double bond. After drawing the carbon-carbon double bond, you make sure that every carbon has 4 bonds. So you add 1 more, 2 more, 3 more, 4 more. That's how you got the ethene. And likewise for propene, you draw the carbon-carbon double bond. And because propene has 3 carbon, you draw 1 more carbon to it. And make sure that every carbon atom must have 4 bonds. Likewise for butene, first you draw the carbon-carbon double bond, then you draw, because but has 4 carbon, so you draw another 2 more carbon, altogether 4 carbon. But in any alkene, there should be only a single carbon-to-carbon double bond. There's only one carbon-to-carbon double bond. The rest must be carbon-to-carbon single bonds. And then if you are with all the other bonds of carbon, make sure every carbon must have 4 bonds. Alkenes are unsaturated hydrocarbon. Unsaturated means they contain carbon-to-carbon double covalent bond. And you can see here, between the carbon-to-carbon, there is 2 pair of shared electron, represented by a double bond. So in this C2H4, carbon-to-carbon double bond is formed by the sharing of 2 pairs of electrons between the carbon atoms. Isomerism in alkenes. Butene and methylpropene are isomer. Why they are isomer? Because they have same molecular formula of C4H8, but they have different structural formula. And because of that, they have different physical property. For example, butene, it should be Butene. Butene has a boiling point of minus 6.3 degrees Celsius, and methylpropene has a boiling point of minus 6.9 degrees Celsius. There's a slight difference, but there's a difference. So how do they look like in terms of structure? In our notes, I think there's a mistake here. Each butene must have 4 carbon. So in other words, let's draw here. It should be carbon, carbon, carbon. Okay, you must draw the carbon-carbon double bond. and then you fill up the rest with hydrogen. So there's a mistake in your notes, please correct it. The butene should look like this. And check that every carbon has 4 bonds. So this is wrong. And this is also a straight chain alkene. Okay, it's not this diagram, okay? This is the diagram. Now, as for the methylpropene, is a branch. So this is the main, and then this is the branch attached to the main. Okay, let's try this question. Two alkene molecules are isomer. Which property will be the same for both molecules? By definition, you should know there's one difference. The structural formula must be different. Because by definition, isomers are having same molecular formula, different structural formula. So this cannot be in the answer. How about general formula? And since they are alkene, they must have same general formula. And isomers will have same molecular formula. Let's see whether any answer is 2 and 3. 2 and 3, 2 and 3. Okay, it can be A or this. Because the molecular formula is the same, empirical formula should be the same. So answer is A, 1, 2 and 3. Next question. Alkenes L and M are isomers. Which statement of L and M is incorrect? Incorrect. Isomers. They cannot have the same boiling point. So answer should be D. Isomers should have same molecular formula, and therefore they have same empirical formula. Because molecular formula, for example, C4H8, if they are both C4H8, obviously they can be reduced to CH2. Same empirical formula because of the same molecular formula. And because of the formula, molecular formula is the same, they have same percentage by mass of carbon. Percentage by mass of carbon, for example, using this as example, the mass of carbon itself, 4 times 12 is the relative atomic mass of carbon over the mass of a molecule. 4 times 12 plus 8 times 1. Then multiply by 100%. And this is percentage by mass of carbon over the whole molecule. Next, we will touch on the properties of alkenes. As the molecular size of alkene increases down the hormonal series, the boiling points of alkenes increase. Why? The explanation should be same as for alkenes. So you can see that the boiling point, when it becomes from 2 carbon to 3 carbon to 4 carbon, as the molecular size increases, you realize the boiling point increases, and they are still gases at room temperature and pressure. So why is it the boiling point increase? Okay, this is similar to alkane. It's taken from the slides of the alkane. With the alkene hormonal series going down, when the size increase, intermolecular force increase. Therefore, more energy is needed to overcome the intermolecular force. Hence, the melting boiling point increases. Similar explanation to the alkenes. Now, alkenes are much more reactive than alkenes. There's one common reaction between alkene and alkane, it is combustion. Alkene burns in excess air to form carbon monoxide and water vapor. Likewise, if it's insufficient air, insufficient oxygen, you form carbon monoxide and water vapor. Alkenes contain a relative higher percentage of carbon than the corresponding alkane. Corresponding means having the same number of carbon. For example, C2H4 compare to C2H6. Now, the corresponding alkane of this alkane is C2H6 because same number of carbon. However, you realize that alkane contains more hydrogen than alkene. And based on the formula we used to calculate percentage by mass of carbon, you realize that the amount of carbon is the same, but the whole molecular mass, the alkene, is smaller. So since the numerator on top is the same and denominator is smaller for alkene, so alkene has higher percentage of carbon. Okay, how does it work out? 2 times 12 over 2 times 12 plus 4 times 1 as compared to 2 times 12 over 2 times 12 plus 6 times 1. If you find in terms of the percentage by mass, which one is the larger figure? Obviously, this will be the larger. Next. Because of this carbon-carbon double bond, alkene can undergo addition reactions. So, this special carbon-carbon double bond, please learn how to write properly. Carbon-carbon double bond. Alkenes are very reactive because of this. And all these addition reactions are contributed by the carbon-carbon double bond. And these are addition reaction. Why? You must know the definition of what is addition reaction. In an addition reaction, an unsaturated organic compound combines with another substance, or is it atoms or group of atoms, to form a single new compound. As good as saying 1 plus 1 equal to 1. You see, this is carbon-carbon double bond. When combined with another molecule, this XY will break. X will join one carbon, or the Y will join the other carbon when the double bond opens up. So the double bond is gone. You form a single bond now. So this is called saturated. And this is a single compound that's formed from the addition reaction. So addition reaction produce only a single new compound. Okay, let's look at all the reactions of alkenes in terms of addition reaction. First is hydrogenation, addition of hydrogen. Let's look at addition reaction of alkene. First is hydrogenation, the addition of hydrogen to alkenes to form alkanes. Must remember that. So alkene can become alkane by adding of hydrogen. Condition very important. Temperature 200 degrees Celsius, nickel catalyst must be present. Now, in the presence of 200 degrees Celsius and nickel catalyst, the hydrogen molecule will break into hydrogen atoms. The carbon-carbon double bond may be broken down to form single bond. So this double bond forms a single bond, and these two new bonds, hydrogen is added to it to form an alkane with the same number of carbon. So ethene will form ethane. If it's propene, you'll form propane. If it's butene, you'll form butane. Basically, you're adding two hydrogen to the alkene molecule to form the corresponding alkane. Which statement about the reaction of ethene with hydrogen is correct? Do you need sunlight? No. Reaction is carried out at 60 atmosphere. Is there pressure mentioned? No. The product has a lower molecular mass than ethene. Is it possible? No, it's not possible. When A plus B form a single compound C, C must be of greater mass. C must be having the mass of A plus B combined together. So this statement must not be true. So product is alkane? Yes, it forms the corresponding alkane. If I give you ethene, you form ethane. Bromination, adding a bromine. Addition of bromine to alkene will form bromoalkane. For example, when bromine is added to ethene, one bromine will be added to each carbon atom when the carbon-carbon double bond opens up. So once it opens up, they form these two new bonds. And these two new bonds comes from the breaking down of the one of the double bond. And these two new bonds will actually join the bromine. So it's called 1,2-dibromoethane. Now why 1,2? Because if you label the carbon, okay, this carbon 1, carbon 2. So it's carbon 1 and 2. 1,2-dibromo. Di means 2. Okay, 1,2-dibromoethane. And this is a very important reaction because it can be used as a test for the presence of unsaturated hydrocarbon. It can be used to distinguish between an alkane and alkene. So it can differentiate between alkane that is saturated and alkene that is unsaturated. And the result is ethene decolorized reddish brown bromine rapidly. All these circle words are very important. Remember this particular phrase or sentence. Ethene decolorized reddish brown bromine solution rapidly. And what you observe is reddish brown will turn to colorless because bromine is reddish brown. But ethane does not decolorize bromine solution under normal condition. Do you remember when we learned in the previous video, alkane can react with chlorine and bromine, but there must be UV ray present. So under normal condition, ethane does not decolorize bromine, but only in presence of UV, then ethane can react with bromine slowly. And of course, in this case, when you're testing for saturated, unsaturated, or testing for alkane, we are not having UV ray here, and the reaction is very slow even if there's UV. So down here we say that ethane does not decolorize under normal condition. In other words, doesn't have special condition. So bromine remains reddish brown. Let's try this quiz. The alkene C4H8 reacts with bromine to form a following compound. Now look carefully at this compound. Which one do you think should be the formula of this particular alkene that can form this product? Now take note that this is a branch alkene previously. So it cannot be A, it cannot be B. It's either D or C. Then you count again. There are 4 carbon atoms in the product. And if you look carefully here, 1, 2, 3, 4, 5. So this one is out. Because the number of carbon cannot change, transform from alkene to whatever bromoalkane. So this is the answer actually. Now if you take away this bromine, the double bond is formed between these 2 carbon. And actually same as this, except that it's a mirror image. Answer is C. Hydration. The addition of steam, water at high temperature to alkene will form alcohols. So take note of the condition, very important condition. High temperature 300 degrees Celsius, 60 atmospheric pressure, and phosphoric 5 acid as the catalyst. Now, learn the formula for phosphoric 5 acid H3PO4. So these 3 conditions must be present for the steam to react with alkene to form alcohol. Likewise, the product must be the corresponding alcohol. Ethene from ethanol. If it's propene, it forms propanol. So how does it work? At this condition of high temperature 300 degree, 60 atmosphere, phosphoric 5 acid, this steam will break down to form a hydrogen and a OH. Now this hydrogen will attach to one of the carbon and OH attached to the other one. So to form the corresponding ethanol. Let's try this question. Which is the best substance to distinguish between propane and propene? Now we are looking at propane as saturated, propene as unsaturated, of course is bromine. Last but not least, addition polymerization. Now this very big word, polymerization, refers to joining of similar or identical units to form a large molecule. In this case, addition polymerization refers to alkene molecules which are monomers. Mono means one, mer means unit. Okay, the mer refers to unit. So a monomer means one unit. They join to form a polymer, which is consists of many units joined together. So the process of joining many small units of alkene to form a gigantic large molecule is called polymerization. And because it's addition reaction, so it's called addition polymerization. Condition: high temperature, pressure, catalyst. Now the details in terms of temperature, pressure and catalyst is not necessary. Just take note that you get high temperature, high pressure and catalyst. So we have n number units of ethene. Under this high temperature, pressure, catalyst condition, they join to form a single unit. And this bracket down here with n means this is repeated n number of times. As good as saying that I have small units, I join to form a long unit. Okay? So this is called addition polymerization. You'll learn more about this under the chapter of macromolecules. This is end of part 2 of 3 video.